Alright guys, so I have this problem here, and I have a bunch of stuff after. This should cover everything in one video. It's going to be kind of long, so bear with me. 50 grams of propane reacts with 150 grams of O2 with a delta H of negative, that should say 2221.704. I'm missing a 2 right there. Kilojoules per mole. What mass of CO2 is formed? How much energy will be released? And there's a bunch of other questions besides that. So the first thing I would do, is write my reaction. So I know I have C3H8 plus blank O2 to give me, now what type of reaction is this? If it's something reacting with oxygen, it's going to be a combustion reaction. So my product's going to be blank CO2 plus blank H2O, and both of these are going to be gases. Actually, everything in this reaction is a gas. So why don't you guys go ahead and take a second to balance the reaction. I've already done so pause it. All right, go for it. And it is 1, 5, 3, 4. Now one thing I'd like to note here is, see how your delta H is negative? Negative 2,221.704 kilojoules per mole. You can actually write that into your equation. If it's negative, it's going to go on the product side. So plus 2221.704 kilojoules. And the reason you do this is so that you can use this in a mole-to-mole ratio. For every 3 moles of CO2, I make this many kilojoules of energy. So to go with the first question, what's the mass of CO2 formed? Well, I'm going to have to take all of the masses that I'm given, which is going to be the 50 grams. It's 50.0, sorry, so 3 sig figs. We're going to do all of our answers to 4 sig figs, by the way, just to keep things simple. So that many grams is C3H8, and then 150 grams of O2. So we need to see which one of these is going to be our limiting reactant. So we're going to go ahead and go through, turn this into moles. And to do, once you get your molar mass, you should get something similar to this. And 1 mole of C3H8. And then, I'm not sure why this is so shaky. Anyways, okay, so now we need to know the mass of CO2. So 1 mole of 1 mole of C3H8 gives me, since mole-to-mole ratio, 3 moles of CO2. And then let's just go ahead and take it all the way to grams, since that's what it's asking for. 1 mole of CO2. That many grams of CO2. And it works out to be 44.009 grams based on the periodic table I used. And let's go ahead and set up the other one real quick too. So 31.998 grams of O2, right? Because it's O2, so 16 times 2, but the periodic table uses a little more precise. Is in 1 mole of O2. Then for every 5 moles of O2, I'm going to make 3 moles of CO2. And then 1 mole of CO2 is going to give me 44.009 grams of CO2. So when you mass it up, you're going to get 149.7 grams of CO2 and 123.8 grams of CO2. Now use the number that you have in your calculator from this point on. This is just the rounded number. So, oh my gosh. So to answer the first part, I'm going to get 123.8 grams of CO2. So how much energy will be released? This is where it works in our favor to have it as part of the reaction. I know that I made 123.8 grams of CO2. I'm going to convert this back into moles so I can use my mole to mole ratio. So 44.009 grams of CO2 is going to give me 1 mole of CO2. And for every 3 moles of CO2, I get 2,221.704 kilojoules. Now these kilojoules aren't a number like that you're going to have to memorize. They're usually given in the equation, or in the question itself. So when you do the math here, you end up finding the rounded number is 2083 kilojoules. That is how much energy is going to be released during this first reaction. So 2083 kilojoules. So the next question is, how much of the excess reactant remains? So for this, I'm actually going to go ahead and let me see if I can get this a little tighter. So since this is my max yield right here, I'm going to go 123.8 grams of CO2 times 1 mole, or shoot, not mole, 1 mole on the top of CO2 gives me 44.009 grams of CO2. And I'm going to revert it all the way back to propane, because since that was in excess, I need to know how much I used. So for every, based on our equation, for every 3 moles of CO2, we needed 1 mole of propane, C3H8. So 3 mole CO2, 1 mole C3H8 times 1 mole C3H8 is 44.097 grams C3H8. So when you do all that in your calculator, you are actually going to get 1.3 grams of C3H8 used. Don't make this mistake. That's what you use. That's not what you have left over. So I'm going to take my original mass, 50.0 grams, minus the 41.3 grams. And again, keep the number that's in your calculator. That is going to give me 8.656. This is where I started using the 4 sig figs when I worked this out before, so sorry that the first few answers only have 3 sig figs. Grams excess. So that's how much we have left over. So the next question, how much more of the limiting reactant will be needed to completely react this excess? So we're going to do the same thing we did in the beginning, except for we don't have to work out two problems. We only have to work out one this time. So, not a good idea to use the same color. What happened? Okay, so 8.656 grams of C3H8. So that basically means how much more O2, we can cross that out since we know it, O2 will be needed to completely react this excess that we calculated right here. So this is the excess, 44.097 grams of C3H8 in 1 mole of C3H8. And then go back to our mole to mole ratio. 1 mole of C3H8, 5 moles of O2. So 1 mole C3H8, 5 moles of O2. And then for every 1 mole of O2, I'm going to have 31.998 grams of O2. Give you a couple seconds to punch that in your calculator. And for this, I get 31.41 grams of O2 are going to be needed to completely react. So the next question, and again, it won't be all of these questions. It's just going to be like 1 or 2 of these questions asked at a time. This is just a way for me to, number 1, save you time in watching a video, and number 2, be able to get my point across. So, it says how much more energy will be released in this reaction. So you have 2 total choices here. You can just go with the mass you've gotten and find out with the mole-to-mole ratio, or you can go with the original mass and do the mass of excess and get the mole-to-mole ratio. Since I have the other number in my calculator, this one, I'm just going to go ahead and go with the this mass right here. So 31.41 grams of O2 times 31.998 grams of O2 for every 1 mole of O2. And then just a reminder, we know that for every 5 moles of O2, we get 2,221.704 kilojoules. So 5 mole O2, 2,221.704 kilojoules. Give you guys a couple seconds to math it up. And the number I came up with was 436.1 kilojoules. So that is how much more energy is going to be released. So what's the total energy that's going to be released? Well, it's going to be the first reaction plus the second reaction. So 2083, I'm just going to use the rounded number here, kilojoules, plus 436.1 kilojoules. And just for clarity, let's draw our line. Put my 0.1 when I add them, that's a 9. That's 11, right? Yes. 4 plus 1 is 5. 2. So that is going to give me 2,519 kilojoules in total that I'm going to produce. And this is assuming that this is a perfect reaction and you always get 100% yield, which is almost never the case. But it's just to go through things with you guys. So, the last question. If the CO2 from the first reaction was collected at STP, what volume will it occupy? Well, there's two ways you can go about this. You can use PV equals nRT, where your R is equal to 0.08206 or 0.0821, as he likes to do, and that's L ATM mole K for both of these. Or you can go with the definition of STP at 0 degrees Celsius, which is 273 Kelvin, and 1.00 ATM, 22.4 liters for every mole. So, the simplest way to do this, in my mind, is to use this conversion factor right here. You can do it the other way. Your answer is going to be exactly the same as mine. But, okay, so the first reaction produced, assuming 100% yield, 123.8 grams of CO2, not O2, of CO2 times, and we need to convert it to moles, right? Or we can't use this conversion factor. 44, yeah, 0.09009 grams of CO2 is in 1 mole of CO2. Oh God, I think my pen's dying. Times, for every 1 mole of CO2, I will have 22.4 liters since it's collected at STP. So, I know I haven't done this the whole time, but I'm going to do it now. Unit canceling. This is something that needs to be done just to make sure, especially in the beginning. Oh, you can see that. So grams of CO2, moles of CO2, moles of CO2, and I just have liters, so I can write that and be okay. Give you a second to do this math, and I get 63.0 liters. We'll go 3 sig figs on this. The 1 is the first insignificant number. So if you use PV equals nRT, you're going to get 63.019. If you use this, you're going to get 63.01, I think it's 2. So either way, since we're going to do this 1 to 3 sig figs, your answer is going to be 63.0. So that should be that. Thanks for sticking around for the whole video. I really hope this helps you guys. Don't hesitate to ask me any questions. And again, I really hope this helps.